Hi everyone. So today I'm going to talk about the functions and some terminology about regarding the functions. We will be talking and learning about the domain of the function, what domain means when it comes to functions, what range means, what the term range means with regards to functions, different types of functions. I will be giving as an example. We will be learning about the vertical line rule, horizontal line rule in the functions, and we will be taking inverse of the functions, and we will compose the functions, which is just like the one function taking another function as a parameter. Normally we are giving numbers to the functions as parameters and getting numbers as a result. But if in the case of composition, we are giving another one function as an input parameter to another function, and we will get another function as a result as the composition of those two functions. So let's start with the function and what function means. Function function you can think of function like a factory which takes an input and produces an output. We have, for example, a 2x plus 1 function here, and it takes a 3 as a parameter and produces 7. And the key idea, the important idea in the function is that you need to give, you need to be ensured that for each distinct input, you end up with distinct one output. If one input produces two outputs or multiple outputs, that graph can be written in the xy axis, but that graph cannot be considered as a function. So you need to ensure one input maps to only one output, not two or three outputs. But multiple inputs can map to same output. That is possible. You can have like one, two, one, three, five. All those inputs mapping to output seven, for example. That's possible. But one input cannot be mapped to multiple outputs. So we have different types of functions. Here you have linear functions 2x plus 1, which has like standard linear formula, linear straight line formula with 2 being the slope of the function and one being the constant. You have quadratic functions like x squared or x cubed, x to the power of 4, etc., which are like the parabola type functions. And square root of functions you have, and 1 over x functions for the reciprocal ones. Of course x cannot be zero. You have exponential functions to the power of x, and you have also exponential decay functions, for example 1 over 2 to the power of x. And you have absolute value functions, which you are also familiar with from the high school, which is like v-shaped for the x values being greater than 0. It will just behave like fx equals x, and for the values smaller than 0, it will behave like fx equals minus x, which will create standard v-shaped parabola when you try to draw in the xy axis, xy coordinates. Domain of a function. Domain of a function is considered as the all inputs that the function can take, and we need to check for the domain of for the inputs. We need to check whether there is an exceptional condition where you cannot put that input. For the polynomial functions, for this example, like for example, you don't have any exceptional conditions. You can put any big value or any small value as an input parameter, and it will create a very big value or small value. That's why domain is considered as from minus infinity to plus infinity, all the numbers or the real numbers. You can give any real number here, and it will not complain. For this one, it will complain when you give it 2, because when you give 2, it will become 1 over 0, and which is not defined. That's why you cannot give 2 as an input parameter. Any number other than 2 you can give. That's why the domain is defined as real numbers minus 2, or the real number set slash curly braces to close curly braces is defined as the domain of that function. For the square root, for the example C, because inside of the square root cannot be 0, it cannot be 0 or can 0, but it cannot be negative. You cannot give any number smaller than 4 to the inside of uh, for the inside. So that's why you cannot give any number smaller than 4. You can give 4 and it will become 0, and you can give any values greater than 4. That's why it is the domain is 4, starting from 4 going up to plus infinity. So we have the domain checklist here. We have already checked the denominator whether it is 0 or not in the example B. This one, second one, has already been checked in the example C. Um, for this one, logarithm of 0 or negative number, we don't have an example, but I can give an example. For example, you have a logarithm x minus 3, and for this number, since the logarithm inside of the logarithm cannot be 0 or negative, you cannot give 3 as an input parameter, since it makes the logarithm 0, which is not defined, or you cannot give any number smaller than 3. So you will end up with giving any number greater than 3, going up to plus infinity, which is the domain of the logarithm x minus 3. Domain of it is 3, excluded 3, going up to plus infinity. Range are the all possible outputs that function can produce. We have already talked about domains, and for example, this linear function has range. You can give any big number as a parameter, it will produce a very big number. You can give any small number as a parameter, it will produce a small number, and there is no exceptional conditions here. That's why range becomes minus infinity to plus infinity, covering all the real set. For this parabola cannot have can have negative numbers, but it cannot produce negative numbers. It can produce 0 when you give 0. It can produce 0, but it cannot produce any negative numbers. That's why the the range of this function is all numbers starting from 0 going up to plus infinity. For this shifted square, also you have a square something plus 3. The minimal value that this part of the function can produce is 0. Minimal value that is 0, and plus 3. It's minimal value. This one can produce is 3. It starts from 3 and going up to plus infinity as you increase x or decrease x, because you have square. And we have example input set, which is the domain set, output set, which is the range set. We have x square, which is an example. Okay, and we have vertical line test. So vertical line test, it's a test which defines whether the graph that you draw to the xy axis is actually a function or not. You are drawing a vertical line which vertical to the x-axis. That's why it's called vertical line test. You are drawing a line which is vertical to the x-axis, and you are checking whether uh, that line crosses your graph one time. If it crosses your graph one time, that means your graph is a function. If that crosses your function multiple times, that means there is an x value which produces multiple values. In the first graph, for example, there is an x value which produces one x value. There is no problem. So that's why this graph is considered to be a function. But for the second one, you have an x value here, but it will produce. It is crossing with the graph in multiple y values. That's why you have a one x value which maps to the two different y values. So that's why it is not considered to be a function. So horizontal line test and vertical line test is defined is determines whether a graph is a function or not, and horizontal line test determines whether a function is a one-to-one or not. When you are drawing a line horizontal to the x-axis this time, and you are checking whether your graph intersects with that line only one time or multiple times. If it intersects with one line, so that means you don't have an x value which produces multiple outputs. sorry, you don't have you don't have multiple x values which maps to the same output. In this case, in the first example, you don't have, for example, multiple x values which maps to the same output. But for the in the second one, you draw this line, horizontal line, and this horizontal line, for example, y equals 10. For this y equals 10, you have one intersection and the second intersection. So you have multiple x values which maps to the same output, same y value, which is 10 in this example. So that is why it is not one to one, because you have multiple x values which maps to the same output. That's why it cannot be considered to be one to one. Inverse of a function. So you have a function and you are trying to take an inverse of that function. You have a domain set for this function. This is a domain set. This is the range set. And when you take the inverse of it, the domain and range are also reversed. You are taking the inverse of fx, and domain set becomes the range set for the inverse function, and the range set becomes domain set for the inverse function. For this is the inverse function, and this range set becomes input or a domain set for this inverse function, and the domain set or input set becomes the output or range set for the inverse function. And you have a y equals 2x plus 1, for example. You are taking how to take this the reverse of it. You need to leave this x alone. So y equals 2x plus 1, y minus 1 equals 2x, and y minus 1 over 2 equals x at the end. And then at the end, y minus 1 over 2 equals x. You are reversing at the end, swapping y's with x with y's, and you will end up with y equals x minus 1 over 2. In this presentation, I I built this presentation with the ChatGPT, and in this presentation, it is doing the swap at the second phase. I am used to do swap at the end, so it doesn't matter. And you need to check if you want to check whether your inverse is correct or not. Inverse of a function, when you compose inverse of a function with the function itself, when you do the composition, they will cancel out each other, so you will end up with x. You can use this method to check whether you correctly take the inverse of a function or not. Composition of functions. I also want to say something about the inverse of a function. So we have talked about horizontal line test and one-to-one functions. So inverse of a function, in order to be able to take the inverse of one function, that function needs to be one-to-one. If that is not one-to-one, you cannot take the inverse of it. Why? Because you have multiple inputs which maps to the, if assuming that you have a one function gx, and this gx has multiple inputs mapping to the same output. So when you take the inverse of gx, you will end up with a value in the value in the input set which maps to the multiple outputs. For example, G1 maps to the 10, G2 maps to the 10, but when you take the inverse of it, 10 becomes input, and 1 or 2, 1 and 2 becomes the output for the inverse function. So you will end up with G minus 1 to the 10, mapping both 1 and 2. You have a 10 as an input parameter for the g minus 1, which is the inverse of g, which maps to the 1 and 2. So that one input is mapping to the multiple outputs. That is not a function. That's why you cannot consider it to be a function. That's why you cannot take inverse of a function if that function is not one to one. And we have composition of the functions, fx and gx. In this example, fx is taking, in this example, fx is taking gx as a parameter. Gx is taking x as a parameter, then fx is taking gx as a parameter, and you will end up with fx equals 2x plus 1, gx equals x square, and x square takes as a parameter 2x square plus 1, 2x square plus 1. And you have here f is taking x as a parameter, then g is taking fx as a parameter, g is taking fx as a parameter, fx equals 2x plus 1, g is taking fx as a parameter here, 2x plus 1 and 2x plus 1 square. And that is 4x square plus 4x plus 1. And order is matters. F gx is not equal to gfx. It might be the case that they are equal, but generally they are not equal. And that is all I can describe about the functions today. There are lots of other things, other elements that I need to mention about functions, but for this video, I believe this will be enough. Thank you for listening. Until next time.